and welcome to KingTech Coding Clinic once again. And in this course, we're going to cover up everything we need to know to get it started up and running in programming. And the course is divided into two different sessions. The first session has to do with all the things we need to get ourselves up to speed or bring ourselves up to speed with as far as the computing curriculum is concerned. So we go through the first session of our training, having our pupils, our students in mind. And we need to try as much as possible to get every detail of what we are going to do, to feed ourselves with this information so that we can be able to deliver when there is the need. So let's look at the first session, the course outline for the first session. With the lesson 1, with the first session, we have 7 different lessons, and each lesson has its content. So let's look at the first lesson. In lesson 1, we're going to cover up with computer software or program. Then from there, we proceed and look at the types of programming languages, where we have low-level languages, high-level languages, and then scripting languages. We proceed from there and look at language translators, where we have compillers and then interpreters. That is what we have for lesson 1. Now let's look at what we have in lesson 2. With lesson 2, we're going to cover up with visual programming language, that is VPL. From there, we proceed to problem-solving process and techniques. We look at that as well. And finally, we wrap up with the lesson 2 with software development process. And that will bring us to the end of lesson 2. With the lesson 3, there we're going to look at programming fundamentals, where we have inputs, processing, and output. From there, we look at variables, how to declare variables, how to name variables, techniques involved in naming variables, the do's and don'ts as far as naming of variables is concerned. From there, we proceed and look at data types, where we have the Boolean, floats, integers, strings, characters, and many more. From there, we proceed and look at basic operators, where we have the arithmetic, comparison, assignment, and finally, logical operators. And that will bring us to the end of lesson 3. From there, we proceed to lesson 4, where we're going to talk of algorithms, pseudocode, flowcharts, and then types of errors we do encounter during programming. We then proceed to lesson 5. And in lesson 5, we're going to look at control structures, where we have sequential statements, selection, decision, conditional statements, in which we have single if statements, if-else statements, relational, logical, and equality operators. And also we have condition expressions, and finally switch statements. And that will wrap up with lesson 5. With the lesson 6, we're going to look at loop, repetition control structure, in which we have for loop, while loop, do while loop, nested loop, and finally loop control statements. From there, we proceed to the final lesson of the first session of the training, where we have functions. In there, we have built-in. We're going to talk of built-in or predefined functions, as well as user-defined functions. From there, we proceed and look at how to call a function. And then we look at passing arguments to functions. And in here, we have a lot to talk about, where we're going to be differentiating between argument and parameters, as this is one of the most confusing topics when it comes to programming. That is argument and then parameters. We're going to go details into that and try to differentiate it for us to be able to know the differences between these two. From there, we proceed and look at pass-by value, pass-by reference. So that will wrap up with the first session of our training. So after that, we then move on to the second session of our training, where we're going to go all out to deal with Python programming. And everything we shall be doing here forms the basics of the programming techniques. So we need to grasp all these basics so that when we go into Python programming, when we talk of variables there, it shouldn't be something new again. We talk of data types, it shouldn't be something new. Because when it comes to this first session, we're going to deal with we are going to solve a lot of algorithms, write a lot of algorithms. And in this first session as well, we're going to write all our algorithms into pseudocode as well as flowcharts. And when we get to Python programming language, we're going to implement them using the codes in Python programming. So we have a lot to cover up, a lot. So we need to beef ourselves up, prepare our minds, and then focus on what we're going to do. So without much ado, let's dive right into the first session of our first phase, or the first lesson of the first phase of our training. Hello and welcome to the first lesson in the first phase of our training. And in this lesson, let's look at the course outline for the lesson. In this lesson, we're going to look at computer software or program. From there, we proceed and look at the types of programming languages. In here, we're going to look at low-level languages, high-level languages, as well as scripting languages. When we are done with that, then we proceed and look at language translators. In here, we have compilers as well as interpreters. We're going to look at what compilers are, what they do, what interpreters are, and what they do as well. So let's look at the objectives of our lesson. So by the end of this lesson, learners will be able to, one, explain what computer programs or software is with examples. Two, explain the two main types of software or program with examples. Three, explain the various types of programming languages with examples. And four, differentiate between compilers and then interpreters. But then, before we go into the contents of this lesson, let us just ask ourselves this question. As ICT or computing facilitators, have you ever sat down, or facilitator, have you ever sat down to think and analyze, ask yourself a series of questions as far as computer is concerned, and then the softwares we use and programs we use in a computer are concerned? Have you ever sat down to ask yourself that these softwares we use, who created them? How were they created? Have you ever sat down to analyze all these things? If yes, have you ever made any move to find out the answers to your question? If yes, have you gotten the right answer? If no, we'll surely get the right answers in here by the end of this training. And have you ever thought of it that it could happen that one of your students can prompt you with this question in the class? Yes, they can do that. They have done worse, and this is just icing on the cake. They can just do it. There's nothing wrong with that. They don't see it as anything. They see you to be the bank of knowledge, so they can ask you any question. They can prompt you with any question at all. So in order for you to be able to stand up for all these questions in class, this training is for you. Let's open our mind, focus on all this, try to learn, having our students in mind, so that when we get to the class, in fact, when we begin to deliver, there is nothing that can stop us. Let's dive right into it. Computer software or program. Now, what is a program or a software? We do use these terms in our ICT lessons or computing lessons, workshop, trainings, seminars. In the use of computers, we do use this. What are they? Now, a program or a software is a sequence of instructions that specifies how to perform a computation or to perform specific tasks. Wow. Have you gotten this? A sequence of instructions. Not knowing all the softwares we use have been instructed to perform some specific tasks that they perform. And these instructions are in what? Sequence. Now, let's look at some of the examples of what the softwares we are talking about here. Let's look at for example, using a Microsoft Office suite in which we have Excel, Word, PowerPoint, Outlook, and all that. You can see that Microsoft Office suites perform a specific task. It is about documents. When you go to the Word, when you take the Word app in the suite is about processing of Word documents, writing of letters, notes, and all that. If you take Excel, it has its specific work it does. The same thing applies to what other softwares, where we have something like VLC player for playing media, videos or audios or whatever. When you come to Mavis Beacon for learning how to type. So you can see that all these softwares have what? Different functions or specific tasks that they perform. So basically that is that. Now, in order for you to explain this to your student in class for them to understand, why don't you get a laptop? Have different softwares or application softwares on the laptop. Try to use them for them to see how each and every software is used for. Then after that, try using, for example, use a VLC media player to play music and videos. And use Mavis Beacon to what? Practice typing. And after that, try using Mavis Beacon to what? Play video, and try using VLC to what? Learn how to type. They get to realize that it's not possible. There they get to know that each and every software has its what? Specific task that it performs. So that is that. Now let's look at the two. So there are two types of what? Programs or software. The first one where we have system software. And then the second one we have the application software. Now let's proceed and look at what a system software is. A system software, a system program controls the computer. In other words, without the system software, we can't use the computer to our satisfaction. We can't get the GUI, that is a graphical user interface, to be able to what? Run other apps or other softwares. So basically, when you boot the computer, the components that load is made up of what? The system software. And what? This is what they are telling us. It controls and maintains the hardware components. The moment you boot the machine, the moment the hardware component begin to what? Interact with one another, that is when what? The system software also begins to load to give you the graphical user interface where you can do whatever you want with the computer. It mainly includes the operating system, and basically that is what we term as what? Operating system. System software is basically what? The operating system, its utilities, and then what? Devices, drivers. Its utilities as the components in them, and then the devices, drivers are the drivers that come with the operating system. We have some of the operating system that come with the drivers pre-installed, and some they come without the drivers. So it means that after installing the software, the operating system, the drivers that you lack for different types of hardware or the peripherals, what you need to do is to go for the drivers and come and install them. Then you can use the hardware component associated with that drivers or that driver. So basically that is that. Now the system program that loads first when you turn on your PC is called the operating system. Basically, when you press the power button and the computer begins to load, the component we see, the program that loads first is what we term as what? The operating system. So now let's look at some of the examples of what? The operating systems we have. Where we have Windows, Microsoft Windows OS, Macintosh OS, Ubuntu, where we have Ubuntu, Linux, and all that. And we also have iOS and then Android operating systems and etc. We have them as many as you can. We also have there is one I just the name just skipped. We have them there. So these are some of the few examples we have. Now let's look at what application software is. What is an application software? Application programs perform specific tasks and runs over system software. What it means here is that we've already explained something like that from the beginning, where we said software performs specific what? Tasks. That is what the application softwares do. They perform, each and every software has its what? Task that it performs. And they run over the what? Operating system. They run over the Windows OS. So without the Windows or without the operating system, we can't run any application software. Now let's look at some of the important uses or advantages of what? Application software. One, it enhances user productivity. To be able to access, type your documents, print them or whatever it is, the word is there to do that for you. So that is what we mean by it enhances user productivity. To be able to maybe compute your students' marks, scores, and all that, Excel does that with magic. It enhances user productivity. They are also used to solve user problems. They encounter problems day in, day out. We have softwares out there that can help us do that. When you take the hospital management system like this, it solves a very big problem where it keeps tracks of what drugs people take, and then maybe the conditions of each and every patient. And whenever they return to hospital, they can trace back their previous day of visit, and then the what they were diagnosed of and all that. So these are some of the problems our softwares help to solve. They also supply us with what information, as well as provides us with what entertainment. These are some of the few importance or uses or advantages of application software we have. We have them as many as you can. So that is that. Let's look at more of the examples of what the application software, where we have the word processors, the spreadsheets, the photo editors, the browsers for surfing internet, and games, and other examples for games for entertainment, and other examples of what application programs. We have them as many as you can, so they are there. So that is what application software is. Now, with these softwares, we ask ourselves how they are made up of. Well, this brings us to another what topic here, that is programming languages. This software, in short, are made up of what? The source of these softwares are from these programming languages. So let's pay attention to what the programming language has to do with the softwares we use day in, day out. Now, what is a programming language, or what are programming languages? So a programming language is a set of commands governed by rules. I like that. They are governed by rules. They are a set of commands governed by rules, instructions, and syntax for creating software. Very good. So that is what we are talking about. This programming language is a set of commands. They are commands that we issue, and then these commands are governed by rules. We don't just type anything at all and say it's a command. There are rules. Each and every programming language has its syntax and rules that govern them. If you misspell something, it throws an error. If you fail to follow the basic rules, you get it wrong. If you follow the rules well, you get it right. So basically, that is that. These programming languages are used for creating our softwares we use. Now, let's look at the types of programming languages we have out there. Basically, there are four general types of what? Programming languages. The first one, we have the machine languages. Second one, we have the assembly languages. Third one, we have the high-level languages. And then the fourth one, we have the scripting languages. Now, let's look at what they are all. Let's start with the low-level programming languages. Now, these low-level programming languages are used to write programs that relate to the specific architecture and hardware of a particular type of computer. So what they are telling us here is this: since we use these languages or programming languages to write our softwares, the low-level languages, where we have the assembly language and then the machine language as the examples of what? Low-level languages. These particular languages are used to what? Write programs that relate to what? Specific architecture and hardware of a particular type of what? Computer. So what they are telling us here is that before you can be able to use either the machine language or the assembly language, you need to be able to what? Understand, be master of what? Hardware component of the computer. Because you have to know the processor, what the processor need to be able to process something. What's the other component of the hardware need? That is what you need to know. You have to be a hardware specialist before you can use machine language. You have to understand the hardware component before you can use either the machine language or what? The assembly language. And these two form what? The low-level languages. So in other words, those who were using these languages, in fact, they didn't find it easy at all. It means they were hardware experts, and that was the reason why they were able to what? Use these languages to communicate with the hardware component of the computer, to the extent that when you press the power button of a computer, the hardware component begin to interact with one another and begin to load the operating system we talk of. So you can see, it means that the programming starts from what? The hardware level. Imagine you just pressing the power button, and a lot of things begin to happen in the triangular box we call the system unit. Did you ask yourself how this has come about? Well, That is the beginning of this programming languages, where machine language and then assembly language are used to what? Communicate with the hardware components. Now, these, what do you call it? Machine language as well as assembly language form the basics of what? The low level programming languages here. So when we are asked to give examples of what? The low level programming languages, these are the what? Assembly language and then the machine language. They are the basics. They start from the hardware level. Before you can use any of this language, before you can learn machine language or assembly language, you need to be boss of a hardware component of the computer before you can do that. So basically, that is that. These languages are closer to the native language of a computer, that is binary. The native language of a computer is what? In binary, that is zeros and ones. That is the only language the computer understands. The computer understands only zeros and one, making them harder for programmers to understand. How can you understand zeros and ones? Just look at these typical examples here. So the following instruction adds two numbers on a certain mini computer. That is machine language instruction. In machine language, where we have this series of zeros and ones, it means two numbers are being added by the combination of these zeros and ones. And in assembly language, this is what it means. It means add A, comma, B. So just look at all these lengthy zeros and ones. It has been summarized. Mnemonics are being used for in assembly language to what? Represent these zeros and ones. So these lengthy zeros and ones in machine language means in assembly language as what? Add A and what? Add A, comma, B. So you can see to program with this wouldn't be easy at all. So they have to find a way out, and that is what brought about what? The assembly language, because it wasn't easy to program with the zeros and ones. So there must be a language that they can use to what? Represent these zeros and ones, use mnemonics to represent these zeros and ones. And that language is what? Assembly language. So let's proceed. So the machine language, we are still on the machine language. This is the only language the computer is capable of what? Understanding directly. They consist of what? Sequence of zeros and ones, or binary digits or bits. So these zeros and ones are basically the language that the computer understands, and that is what? The machine language. Each combination of zeros and ones is an instruction for the computer to perform an operation. The combination of zeros and ones is a simple instruction for the computer to what? Perform instruction. Unlike today, we'll be coming there very, very short. Unlike today, when we use a programming language like JavaScript, Java, Python, and all that, where we write syntax, which are human readable. Gone are the days, it wasn't like that. It started with these zeros and ones, because that is the only language the computer understands. Even with the use of assembly language, where these zeros and ones are combined to form mnemonics and assembly language, the computer still doesn't understand the assembly language. So there must be something happening somewhere to be able to make the computer understand where we had what? Something like this. The computer still will not understand this add A and B. It will not understand it. There must be something in assembly language that will be able to translate this A and B into these zeros and ones before the computer can assimilate and understand and work with. Let's proceed. Good. Now this brings us to what? Assembly languages. What are assembly languages again? A low-level programming language which implement a symbolic representation of the machine code needed to program a given CPU architecture. So basically, the assembly language, as we stated earlier, is also a low-level programming language which implement a symbolic representation. So in a nutshell, what the assembly language does is that with the zeros and ones in machine language, these zeros and ones have been combined to form mnemonics in assembly language. So let's look at a typical example. For example, 100 in machine language means load in assembly language. So you can see that this is very simple for us to what? Use, right? Instead of combining these zeros and ones, everything about zeros and ones, there are words or mnemonics in assembly language that represent that. So when you write this in assembly language, it means this in machine language, which the computer can understand. So that is what the assembly language is. It's a what? Symbolic representation of the machine code needed to program a given what? CPU architecture. So basically, in assembly language, an instruction is an easy to what? Understand and remember. So that is that. You can imagine this 100. It will be difficult for you to be able to remember all these things. It's not easy. But in assembly language, you can just memorize load, store, multiply, add, subtract, and you know what they all do. You write them in assembly language, you understand what they are, which makes it a bit easier compared to what? The machine language. But even with assembly language, can we cope with it? Let's proceed. So let's look at example of what assembly language instruction sets. Now in binary code or in machine language, where we have 0000 4 zeros here, that the operation in assembly language means what? Load X. And in general, it means con into bracket X to what? R or whatever it is. This means that it wouldn't have been easy at this level. So the assembly language has been used, and mnemonics in assembly language has been used to what? Represent these zeros and ones. So when you see 00111, it means add X. So anytime you just say 0011, it means what? Add X in assembly language. But will this be easy for us to learn at all? It shouldn't be easy. So this is the machine language in binary code. This is its operation in what? Assembly language. And this is what it means here. So this wouldn't have been easy for us at all. This wouldn't have been easy. But thanks to the growth of what? Technology. Let's proceed. Now, let's come to assembly language translator. So this brings us to what? The fact that still the computer can still not even understand the assembly language because it contains human readable words like add, subtract, and all that. Yeah, the computer doesn't understand. You and I learn that computer understands only zeros and ones. So how will they be able to understand the assembly language which contains human readable words like add, subtract, and all that? Now, it's a program called an assembler. This word, underline, bold, very well for you to see, translates the assembly language instruction into machine language. The program we call an assembler here is embedded in the text editor that can run the assembly language code. So this assembler translates everything you write in assembly language into what? Zeros and ones. That is the machine language before the computer can understand. So whenever you say add X, it's the assembler translates it to what? Zeros, to the combination of zeros and ones, which says add X, for the computer to be able to what? Use. Now, moving from machine language to assembly language made programming easier. So moving from these zeros and ones to the mnemonics and assembly language, it makes it a bit easier. But then still unpleasant for us to learn. Excuse me, please. Thank you. It was still unpleasant for us to what? To learn. So what is the way forward? So the next step toward making programming easier for you and I today, even though we say it is easy, as today the statement says, to make it easier for us. But are we seeing it as easy as it is? No, it's still not easy for us at all. Because the moment we hear programming today, in fact, we panic. We're going to think, how is it going to be? It's very difficult. We threaten ourselves. We put fear into ourselves. And that is what is driving us away from this. So let's look at what is going to happen. The next step toward making programming easier was to devise high-level languages closer to spoken languages. So the next step forward is, instead of we going into this difficulties writing our programs with these zeros and ones, which is difficult, and we talk of assembly languages where we have mnemonics of these zeros and ones and all that, still it wasn't easy. So they must devise what languages we call the high-level languages, which are closer to what spoken languages that we understand. Let's look at some of them. So high-level programming languages, they contain English words and phrases and what? Algebraic expressions. Basically, if you take our languages, for instance, one of the example of the higher language we're going to learn here is the Python programming language. If you take Python programming language, for instance, there are some human readable words in it that you and I understand. For example, print, function, variable, whatever. We have them, and they are all words that we can understand. We have a lot of statements that we can understand. For loop, while loop, whatever. We understand them. These are all human readable words. And then basic algebraic expressions that we write where 2 plus 2, whatever, 2x is equal to 3 minus 4 over this and that. These are closer to what our words or phrases or terms we use day in, day out in our learning processes. So with this form part of what? High-level languages. So it makes it easier since we can read some of the what? Syntax. And this high-level languages focuses more on the programming logic rather than what the underlying hardware component. Instead of you going to learn about the hardware to be able to program using the machine language or assembly language, This high-level languages deals with what? Programming logic. What you're going to write, or the program you are writing, is there logic in it? Does it make sense? Does it solve a particular problem? So if it does, then fine. There is no need you go and be learning these hardware components all in the name of what? Programming. With the high-level languages we have, you only have to think about the logic involved in your program. If it makes logic, if there is logic in it, then fine, you are good to go. So basically, that is that. Now let's look at examples of what high-level languages. We have C++, we have the COBOL, we have the JavaScript, we have the Python, we have Objective-C, we have Java, we have Visual Basic, and then many more. Say what? Like assembly languages, they must be translated into machine language before they can be understood by the computer. Just like the assembly language, with the human readable, with the availability of human readable words in our high-level languages like Python and Go, where we have print, variable, and all that, the computer still can understand. So the various text editors we use in line with these languages. For example, if we take Python, the common text editor we use alongside Python is what? PyCharm. And visual, what do you call it? VS Code, Sublime Text. These text editors have what? What do you call translators in them. They have translators in them that help to translate this language or the syntax or the source code into what? Machine language before the computer can what? Understand. So basically, that is that. Don't think as we write print and all, the computer understands that. No, it doesn't. The various text editors we use have what? Compilers and what? Interpreters in them that help to translate the source code we write in these high-level languages to what? The machine language, that is zeros and ones, before the computer can understand. Now let's look at high-level language translators. So what? Translators have the responsibility of converting the source code to the machine language, also known as what? Binary or object code. The translators I just spoke about, they are built in the text editors where we write the codes for what? The languages. For example, like I said, the Python, we use PyCharm. So in PyCharm, there is what? A translator there. That helps to what? Convert the source code into what? Machine language. It helps to change the source code from this print and other stuff to what? Zeros and ones to them, for the machine to be able to what? Understand. And when this source code is translated, it becomes what? Object code. That is binary. It becomes zeros and ones. And that is where the computer understands. So when someone asks you, when someone prompts you to maybe answer, what is object code? This is a code or the source code that has been what? Translated into what? A binary code, or into what? A machine language, or into what? A language that the machine understands. That is what an object code is. The high-level programming languages are translated into machine language by interpreters and compilers. I've just said it earlier. So basically, our high-level languages that we are using today, they have interpreters and compilers in them that help to translate the source code to the understanding of the machines. That is what? Zeros and ones. So basically, that is that. Now let's look at the compilers as well. So a compiler translates computer code written in one programming language, that is the source code, into what? Another programming language, that is the target language or object code or the executable. It's the same thing. What the compiler does is that it translates the computer code written in what? One programming language. Example, if you write a program using a C++, what the compiler does is that it translates the source code from this C++ to what? The object code. That is the code, that is the zeros and ones, that is the executable, that is the target language, and that is the machine language. This compiler translates the source code from C++ to what? Zeros and ones for the computer to be able to what? Absorb, understand, and then process and give us the feedback we need. Sorry. Now let's look at, so compilers read the, now we are let's try to understand something here. The differences between compilers and then what? The interpreters. Good. Now, I said the compilers read the entire program and translate it completely before the program starts. So what they are telling us here is that after writing the source code, what the compiler does is that it takes the whole source code in bulk, translates it once and for all, and then hand it over to the machine. Translate it into what? Zeros and ones, and then hand it over to the machine before the machine even starts running it. So basically, that is what the compiler does. We'll be seeing the differences between the two as we move on. Examples of such languages that use this compiler are, we have the Ada. The Algo, the C, the C++, the C Sharp, the Objective-C, the Swift, the D, the COBOL, the Java, Basic, and Clio, and then Crystal, etc. We have many more of them that uses compilers. So basically, that is that. Let's look at the interpreters. Like I said, compilers and interpreters are similar, but there is a slight difference. That is in terms of what? The way they translate the codes, the way they translate the source code. What they all do is that they translate the source code into what? Language that is zeros and ones, or the object code. But how that does the interpreter do, and how does the compiler do in terms of the translation? That is what give clear differences between the two, which we'll be talking about in a couple of minutes. So in an interpreted, or what the interpreter does is that the translator processes the source code line by line. In short, what the interpreter does is that instead of the compiler, unlike the compiler, that takes the entire source code completely, translate it, and hand it over to the machine before the machine begin running. What the interpreter does is that when you begin running your code, it checks every line. It goes to the first line, read it, come to the second line, read it. So if there is any error in one of the line, it prompts you, you make sure you fix this error before it proceeds to the next line. Unlike the compiler, that finishes everything before it tells you that there is error in this line, there is error in this line, before you have to go back again. Imagine if you have billions of zillions lines of codes. How are you going to manage this? It wouldn't be easy. So at the end of the day, you should be able to see and understand the differences between what? Interpreters and compilers, and then the advantages and disadvantages involved in their use, the two of them. The two of them translate the source code from any language to what? The machine language. How do they do it? The compiler takes the whole source code after what? Writing it, translate it, and hand it over to the machine before the machine begins to run. But the interpreter runs it line by line, line by line. It will go to the first line, read it, come to the second line, read it, come to the third line, read it, come to the fourth line. If there is error there, it will stop there, prompt you through error, and then tell you that fix this before I proceed, else I wouldn't proceed. So that is what the interpreter does. So this means that interpreter source code start running until it encounters an error. Then the interpreter stops to report such errors. Exactly what I'm talking about. It will start running. It will go to the first line, run it. Come to the second line, run it. It will not stop until it detects a problem. And once the problem is detected, it stops there. It will prompt you to what? Fix the bug, fix the error before it proceeds. So that is what the interpreter does. Now let's look at examples of what? Languages that use the interpreter. We have the APL, we have the Basic, we have the Lisp, we have the GNU Octave, we have the IDL, we have the Mathematica, we have the MATLAB, we have the JavaScript, we have the Lava, we have the Game Maker language. We have them many more as you can think of. You can search for more of them. We have them there. Now let's try comparing the compilers and then the interpreters. The interpreter translates the codes line by line and execute the line before going to the next line. What the interpreter does is that it translates the source code line by line. It will go to the first line, translate it. After that, it will come to the second line, translate it. After that, it will come to the third line, translate it until it gets to the last line. But how does the compiler do it? The compiler translates all the lines of code in the program to a file, that's the binary, and execute the whole file. So what the compiler does is that it takes the whole source code, translate it completely into what? Object code before handing it over to the machine. That is when the machine will what? Understand. Now let's come to the interpreter again. The interpreter takes less amount of time to analyze the source code, but the overall execution time is what? Slower. It takes what? Less amount of time to analyze code. What it means is that if there is an error, during the runtime, it will detect an error. So this makes it take less amount of time to analyze the source code. But the overall execution is slower because it takes it time to go through every line of code. So, in fact, the overall execution is very slow. It wouldn't be easy. If you have many lines, it wouldn't be easy. But with the compiler, it takes large amount of time to analyze the source code. But the overall execution time is what? Comparatively faster. Although, the compiler takes a lot of time to what? Analyze the source code. But the moment it does with the analysis, the execution time is what? Faster. So that is that. The interpreter continues translating the program until the first error is met, in which case it stops. Hence debugging is easy. So as it's running, as the compiler is going through the lines of code and all that, it will stop when there is an error and ask you to fix it before it proceeds. But with the compiler, that is the interpreter. But with the compiler, it will finish running everything before giving you errors. So that's what I'm saying. If the codes are many, you become frustrated. You can't fix them. So that is the differences. Now let's look at the examples once again. Languages like Python, PHP, Perl, Java, Ruby use interpreters. Languages like what? C, C++, C Sharp, Scala, TypeScript use what? Compilers. So basically, that is that. Now let's look at scripting languages. So scripting language is a high-level programming language which with a series of what commands designed for integrating and then communicating with what other programming languages. These scripting languages are what? Also high-level languages with series of commands designed to what? Designed for integrating and communicating with what? Other programming languages. Integrating and communicating with other programming languages, what we're going to explain here. Now, how do we integrate these scripting languages into other programming language? For example, if you're using Python to write a software or to design a software, and you come to the designing process, we have a Python module that is called the TK-Inter that is used to design graphical user interface. But there are some that might not want to use the TK-Inter for the graphical user interface, but still they would want to style their website, or sorry, their program or whatever. So what they can do is to what? Go for one of the scripting language like what? HTML. Call the HTML here. Use some of the HTML code to do the external design, and use CSS to style it. So you can see that scripting language has been what? Integrated into what? Python. So that is what we mean by what? Integrating and communicating with other programming languages. So basically, that is that. Scripting languages are usually termed as what? An interpreted language, since each line of code in the program is translated at runtime. The scripting languages are also known as what? Interpreted languages, because each line of code in the program is translated as it's run. It will go to the first line, translate it, second line. If there is an error, it stops there and then show an error. So that is what makes it what? Also an interpreted language. So some scripting languages include, we have the Python, we have the JavaScript, we have the PHP, we have the HTML, we have the CSS and all that. These are all scripting languages. Now let's look at the high-level languages versus the low-level languages. So with the high-level languages, they are easy to learn and understand. But with the low-level languages, they are challenging to learn and understand. The high-level languages are executed slower, and you know why. If you don't go back to your note and then revise and get back to this answer. They are easy to what? They are executed slower. But with the high-level, the low-level language, they are executed faster. Explain why. The programs are easy to modify. And but with the low-level languages, the programs are difficult to what? Modify or change something in it. For writing a program, so imagine you writing a program with what? High-level language like Python. If you meet another Python developer, he can easily modify or change a program. But imagine you meet any programmer at all who does not know anything about these zeros and ones. How can one modify a program written or program written by what? Low-level language like what? Machine language, which is zeros and ones, or assembly language. It will be difficult for the program to be what? Modified. For writing a program, hardware knowledge is not required. For you to use the high-level language to write a software or a program, you don't need hardware knowledge at all. If you have it, plus. If you don't have it, no problem. For writing a program using what? Low-level languages, you don't need that one. The hardware knowledge is what? It's a must. You must understand the hardware component of the computer. You have to understand how the hardware component work before you can use the low-level languages. Examples of the languages are below. You can quickly read them once again. Where we have the high-level language, we have the Python, we have the Java, we have the Perl, we have the Pascal. These are some of the examples of high-level language. The low-level languages, we have assembly language, and then we have the machine language. These forms examples of what? Low-level languages. Now let's look at the abstracting level of programming languages. Initially, it starts from the hardware level, where this particular machine language is used to communicate to the hardware. As time goes on, they get to realize the difficulties in this. So they have to implement another language we call the assembly language, which is a symbolic representation of what? This machine language. Where if machine language says 0111000, there is a word or phrase in assembly language that translates that. So basically, this is how it started. And from there, they got to realize that programming with machine language as well as assembly language wouldn't be easy at all. So that was when they introduced high-level languages, such as what? C, C++, Java, Python, PHP, and all that. Now, in summary, it all started with machine language. From there, we proceed to what? Assembly language. And we come to the various, languages we have, such as what? C++, Java, Python. We have pseudocode and all that. So what is what? A pseudocode. A pseudocode is just like a false code. Unlike the original code we write in Python, JavaScript, or whatever. A pseudocode is a false code. I see pseudocode like a drawing or a sketch of an artisan. And then after sketching, the artisan looks at the rough work of the sketch and do the original work. That is what pseudocode is, basically. So that is that. And these assembly language are closer to what? Human readable words. So let's take note of what? That is the assembly language. They are closer to what? Human readable words. As well as, what do you call it? The high-level languages such as Python, Java, C++. They are also what? Closer to what? Closer to what? Human readable words as well. So basically, that is that. So we have the low-level languages here. We have the high-level languages here. We have the natural languages here, which we all know. Our own languages we use to speak English, Spanish, Japanese, and all that. So basically, this is the summary of this. So I think this brings us to the end of the first lesson of the first session of our training. So we wait and then proceed and look at what we have for the second lesson. But the summary and what I would like is to take away from this first lesson is this. We now know what softwares and programs are. We know the examples of them. We also know how how they are made up, or what makes up the software. And we can also differentiate between the application software as well as the system software. And then we also look at the various languages, how the computer programming starts, and the language that it started with, and the language that the computer understands. You have to take note of all these things. So you should be able to have all these things at the back of your mind. So basically, these are some of the things. And then, as we said, the computer doesn't understand any language apart from zeros and ones. But today, there you go writing programs in Python and JavaScript and Java and C++, C Sharp, and then all that. How does the computer understand that? Answer this question. Tell them that the various high-level languages we have, that we've just mentioned here, Python, C++, and all that, have text editors where we write the codes. And in these text editors, we have the compilers and then interpreters in them that help to translate our source code to what? Object code, or to the machine language for the machine to be able to what? Basically understand. So these are some of them. We need to be able to know the difference between high-level and the low-level languages as well. So this brings us to the end of this lesson. Thank you very much for watching, and see you in the next lesson. That is lesson 2. Bye for now.